Troubleshooting a tachometer system. A faulty tachometer doesn't just output an incorrect reading. It can silently cause engine damage, reduce propeller life, and trigger false alarms. Troubleshooting a tachometer requires a precise, step-by-step approach. Your job is to catch faults early and prevent failure. Let's start with a common red flag: low RPM readings in propeller aircraft. A low reading can mask overspeed conditions where the propeller is spinning faster than safe limits, adding stress and reducing blade life. Always cross-check cockpit readings using a calibrated handheld tachometer. If the deviation is greater than plus or minus 10 RPM per heart cell's instructions, recalibrate or replace the unit. Not all tachometer faults are electrical. Mechanical systems have their own failure modes. Mechanical tachometers, especially older ones, can stick during ignition checks. A real drop of 200 RPM may only show as 100 masking the issue. A temporary fix, like tapping the gauge, may free the needle, but this signals internal wear. Always remove the unit and bench test it to ensure integrity before reuse. Now, let's look at turbines, where precision is measured in tenths of a percent. Turbine engines use N1 and N2 tachometers with allowable deviation of only plus or minus 0.1%. Readings outside this limit may indicate sender faults, connector issues, or wiring defects. Confirm with a calibrated analyzer. If the discrepancy remains, shut down the engine and document the fault before further operation. Engines like the Jabiru require especially precise tachometer calibration. The sender gap must be exactly 0.4 millimeters or 0.016 inches, and the flywheel tag should cover 60% of the sensor face. Even minor misalignments can cause erratic readings or trigger false alarms. Visual inspection during maintenance is essential to ensure sensor accuracy. Let's walk through a real-world scenario. A technician is called for unstable RPM readings on a Jabiru engine. First, they compare the panel gauge with a handheld tachometer, and the readings don't align. During an ignition check, the needle sticks, indicating gauge wear. Finally, inspection reveals the sender gap is too wide and the tags are misaligned. This is a classic case of multiple compounding issues. In turbine engines, small deviations can mean big trouble. The fix? Realign the sender, replace the worn mechanical gauge, and confirm accuracy using a calibrated analyzer. This wasn't a single-point failure. Multiple small faults created a significant operational risk. An inspection mindset keeps aircraft safe and systems reliable. Troubleshooting takes patience, precision, and process. Use the right tools, follow tolerances, and confirm each step. Inaccurate RPM isn't just a number. It's the real risk.